Right, we just did estimating the initial mean number of views for videos to be on YouTube's trending list. So it's from Kaggle. 127 days of metadata of top trending videos are collected from 5 countries. It's dependent on social interactions, how videos become trending. And then the metadata for views, shares, comments, and likes are all correlated, but they all go into the trending algorithm. The thing is, publishers can disable embedding, comments, and likes, which can skew the data set even more. So the view is the true indicator. You can't censor views to go on trending. So, and then all subsequent interaction could result. So from there, it could be videos can be on a trending list for multiple days, and we're only concerned about the initial view count for it to be on trending. So, and also a video can start trending within a few hours since published, or from old as 2010 from the data set that we collected. And then, so from simple random sample, it's basically we have an unclean version and then a clean version. And then, give me a sec, sorry. Got ahead. So first we data clean it. And the limitation of the data collection is we cannot capture exactly when a video starts trending. That's not within the data set. Older videos may have started trending a long time ago and have an inflated view count. Data is collected once a day, and time is relative to when a video is published. So that means a video would have been trending like 23 hours ago or a minute ago when it enters the feed. So from that reasoning, we removed the outliers and only kept the data within the 1.5 times the interquartile range. So it looks better in the clean version. And then after we clean it, we noticed that the new population value is less than 10% of the original population without duplicate observations. So that means the FPC adjustment is ignored. So from simple random sample, real quickly, this is the old, this is the new data set that we're using for the analysis with n equals 44,000. And then the 95 confidence, using the 95 confidence interval threshold, we chose the margin of error to be 5,000 views. So then we get 1847 samples for a simple random sample. And then from there, we get a mean estimate of 91,000 views and a standard error of 2,400 views. And given that the true mean of 93,000 views is within the standard error range, so for a simple random sample, it passed. For the strata exploration, there could be different ways to divide the strata, but we chose category. So there's the different categories: auto, comedy, and whatnot. And then briefly, you can see the distribution of the box plot of the different categories. So most observations will be entertainment, least observation will be nonprofit, most mean will be music, the least mean will be nonprofit. It's color coded, but most standard deviation will be science and tech, and then the least standard deviation will be nonprofit as well. So that's how we first just do some exploration of the strata dependent on the categories that we chose. And then from the stratified proportional allocation summary, first we used 1847, and then we got a standard deviation of 2,500, which is right here. And from there, we did a cross comparison. So simple random sample from the previous slide is within this confidence interval, and then the absolute difference from the true mean is 1,900. And then we do a regular proportional allocation of 1847, and the standard error is larger, and it's not within the confidence interval. So to compensate for that, we did a design effect. So we just divided the standard deviation from the proportional from the simple, and then we got a new sample size of 1893, and then we used that to recalculate proportional allocation again, and then after that it looks a lot better, so it's within the confidence interval, and then the absolute difference from true mean is also a lot better in the green. And then you can see how it's divided. It's among the categories. when we do the 1847 or the 1893 for the different categories for stratification. So, and then we go to straight conclusions. This is like a summary slide. So once we did that 5 times, basically, actually, sorry, like my scroll bars were not working. So the conclusions of the procedure times 5 would be, we did a, this is just like all the views, like there's like 80% of simple random not within the confidence interval, 60% of the proportional allocation not within the within the confidence interval, sorry, and then the proportional allocation, 80% is within the confidence interval. So everything has a mean estimate not within the confidence interval, given that the true mean is 93,000 views. So from there, this is the summary slide. We just did like 80%, 60%, 80% for the true mean within the confidence interval, and then we did an average of the absolute difference from the true mean, and then the proportional allocation after design effect is apparently the best for our data set. And then the standard error is also the least for, obviously. And then for our data set, the proportional allocation after design effect is the best method, and it has the lowest absolute difference from the true mean, and then it's 80% that the true mean is within the confidence interval after 5 times the procedure. Other data will be like music are harder to get on trending, nonprofit might be easier to get on trending, and then use other social platforms to increase social interactions to get on trending. That's our presentation.
Any questions? Okay.